protein structure and the interactions between proteins, fat, and water are very important to what goes on in living things. And when we cook or bake, we're actually able to manipulate these variables in so many ways to gain a better understanding of them. And it's such a great way to learn about these concepts because food's something that we're all familiar with, and baking is super fun and accessible. We can use our kitchen as a science lab and end up with something to eat at the end. Also, having background knowledge in the way proteins, fat, and water work is super helpful in being able to execute and create your own recipes. So I'm going to show you a simple recipe with some biological explanations, and at the end we will have a better understanding of proteins and some very helpful baking tips. Today I'm going to show you a very simple cookie recipe with just eggs, nut of your choice, or nut flour, sugar, salt, and then flavoring. I'm using cardamom and rose water and walnuts, but you can use anything to customize it to your liking. It's great for people with allergies because it has such few ingredients and doesn't contain any dairy or gluten. For supplies, you're going to need a food processor, egg beater or electric whisk, and a clean bowl. You really need to make sure the bowl is clean, does not have any oil residue in the bowl, because the fat molecules will interrupt the process. So first I'm going to take the walnuts, I'm going to roast them and then throw them in the food processor. Walnuts and eggs are living things, meaning that they are composed of the 4 macromolecules, which are lipids, also known as fat, carbohydrates, proteins, and nucleic acids. Walnuts are primarily fat, so we're going to try to keep it separated from the eggs. The goal is to separate the fat from the protein. So eggs are mostly made up of water, fat, and protein. Almost all of the fat is in the egg yolks and the protein is in the egg whites. So when you separate them, make sure you do not get any yolks in the egg whites or you have to start over. Proteins are made up of amino acids, and egg whites contain both hydrophobic or water-hating and hydrophilic, which is water-loving amino acids. When we unravel these amino acids, it's called denaturing the protein, and this process turns the egg whites white. Usually we cook eggs to denature the protein, but we can also do it chemically with an acid or a base, or mechanically like I am doing here. Some people also add an acid to this step, but I find with a high power mixer, the rigorous force is enough. So you'll also notice that it's increasing a lot in size. This is because as we incorporate air with the mixer, the hydrophobic amino acids orient themselves inward as they repel the water in the egg white. So as the hydrophobic amino acids reconnect to each other, it forms nets with air trapped inside. Fat is also hydrophobic, so if we have any fat in the bowl, it would also orient itself inward, and it would reduce the amount of air trapped in the nets and also block the hydrophobic amino acids from linking together. Once I have my meringue started, I gradually add sugar to it. The sugar is the solute, and the water in the egg white is the solvent in this instance. As we dissolve the sugar, it bonds to the water molecules in the egg whites and creates a more viscous solution. Right now, our proteins are forming a big blob with hydrophobic amino acids and air inside, and the hydrophilic amino acids with a kind of syrup on the outside. So this means we get a big fluffy meringue for our cookies with a slightly glossy exterior. The increased viscosity from the sugar also helps stabilize our meringue, as it makes it more difficult for the water to move away and destroy our structure. So just to demonstrate what happens when a meringue collapses, I'm going to scoop some out to set aside and leave that for a few hours. We could also stop here and add our walnuts for a bit of a flatter cookie, but I'm going to continue mixing until it forms stiff peaks. As we continue to unravel more and more amino acids, the nets formed by the hydrophobic amino acids become tighter. So you'll notice that as we continue mixing, the bubbles got much smaller, and the meringue started to form soft and then stiff peaks. With this recipe, we can either create cookies more similar to a French-style macaron by adding a very fine and sifted almond flour, which will result in a homogeneous texture, or we can create cookies more similar to the American-style macaroon by using coarsely ground or chopped nuts or coconut shreds. The heterogeneity of American-style macaroons has more interesting textures and can be both chewy and crunchy, whereas the French counterpart is more melt in your mouth. So it's up to personal preference. However, using a coarse nut and not worrying too much on visuals is much more forgiving and still results in a great tasting final product. As you can see here, the meringue has formed stiff peaks and it sticks to the whisk. This means that it's very stable at this point and will stay mostly intact as we fold in the nuts. I took a quick pause to add in my rose water and just mixed again for a few seconds to incorporate it. If you are using vanilla or almond extract, those contain alcohol, which will react differently than a water-based flavoring because alcohol helps to chemically denature the protein. However, because the protein is already so denatured at this point and will only sit for a few minutes before going in the oven, it should not make too much of a difference in the final product, which is why I add it towards the end, because although it could be added in the beginning and some prefer to do that when using an alcohol-based flavoring, it just increases the number of variables we have to factor in, and I like to keep it as simple as possible. So now I'm going to fold in my ground walnuts, which I mixed with about a teaspoon of cardamom for flavoring. We are gently folding them in so we don't pop all the tiny air bubbles we formed. Since we made such a stable meringue by tightly connecting the hydrophobic amino acids and our nuts are relatively coarse, the fat molecules are unlikely to penetrate the nets at this point. Then we're going to take a spoon and put some cookies out on a parchment paper lined baking sheet, put in the oven at about 325 degrees Fahrenheit or roughly 162 Celsius. Cook until golden on top and browned on the bottom. For me, this was roughly 35 minutes. When we put the cookies in the oven, we fully denature the protein and cause the water to evaporate. This means that there is no longer any chance of the amino acids rearranging themselves. So as you can see, the meringue that I left out for a few hours was unable to return to normal egg whites. This is because I denatured the protein so much and added sugar. So our meringue was very stable, which is great for our cookies, but the egg whites were unable to return to their quaternary structure. However, the amino acids did rearrange themselves, so you will notice that the sugar water solution is concentrated at the bottom now, and the top part has very little liquid left and looks kind of like styrofoam. So we no longer have a blob with hydrophilic amino acids on the outside and hydrophobic amino acids on the inside. Instead, we have the hydrophilic amino acids on the bottom, resulting in a bottom layer of liquid, and hydrophobic amino acids on the top. The hydrophobic amino acids are still bonded together, resulting in a very dry foam with lots of air bubbles still trapped in the nets and leading to a styrofoam-like appearance. So make sure that you don't leave your meringue out for a long time before baking it, and make sure that you don't have any fat in your bowl. Whisk to stiff peaks, incorporate things slowly, and you'll end up with some great tasting, easy to make, quick cookies with very few ingredients.